Hello everyone, in this video I'll be explaining you the problem add on a segment, and it was asked in educational code forces round 185 for division 2. Okay, so let's read out the problem. You start with an integer array A which is initially consists of all n zeros. Okay, you have to perform the following action exactly n times. Okay, so choose two integers L and R, wherein L is greater than or equals to 1, less than or equals to R, and R is greater than or equals to L and less than or equals to N, and assign A of I is equal to A of I plus 1. Basically, from L to R, all the indices value will have to increase by 1 for each I, such that I is greater than or equals to L, less than or equals to 1. The same thing I've said. Like in the range from L to R, all the elements has to be increased by 1. So you are given an integer array B consisting of n integers, again same, both lengths are same only. Your task is to choose such values L and R for each action that after all n actions performed, we have performed this all n actions, it's possible to reorder the elements in such a way that A becomes equals to B. Okay, we can reorder the elements of A in order to make that A equals to B. Okay, now the maximum value of R minus L plus 1 over all actions is as large as possible. Okay, when we are doing n operations, and when we are considering the L and R, the range, so whatever the max range we are choosing among all n actions, so that value will have to display what is the maximum possible value of R minus L plus 1. Okay, so let's take input. So we have test cases, and in each test case we have in the first line we have n as the length of the array B, and then in the next line we have bi elements. Okay, bi all n elements. Okay, array B basically, since array is initially all 0, so there is no array. Okay, now yeah, additional constraint on input is like there exists at least one way. This is very important. There exists this gives initially, like this gives hint like you have the answer. There exists at least one way to choose L and R for each action and reorder the elements at the end of the sign of and all our test case does not exist 2 into 10 power 5. So for all test cases, n is not going to exceed 2 into 10 power 5, which means n log n solution will work, and n square is not going to work. Okay, because 2 into 10 power 5 into 2 into 10 power, basically this is n into n, if you do, which is going to be 10 power 10, so it will exceed TLE. Let's try to take the test cases, and there's been 3 test cases. In the first test case we have 0 5 1 0 0 5 1 0 1. Let's go to the board. Okay, they've given 0 5 1 0 1. This is important example, we'll have to focus on this, but before that let's try to understand the problem statement. So what they're saying is, initially we have an array A. Okay, array A whose size is n and all elements are 0. This is like n length. Okay, size of this is length, and they've given array B also. We have bi elements like b1, b2 up to so on, bi up to so on, bn. Okay, this is also n elements. Now in order to make A equals to B, our task is to make A equals to B. When you're doing that, you'll have to do operations. Okay, so in operations what we'll be doing is you can choose L and R, both are inclusive, and this L is greater than equals to 1. It is 1 based indexing, that's why should be lesser than equals to R, and R should be greater than equals to L, lesser than equals to N. So whenever choose this L and R, it should be within the range 1 to N. And once you have chosen the range, so now what you can do is in A, for array all the array elements E of I, you can increase it by 1 for all for all I which is greater than equals to L, less than equals to R. So in the range you can increase element by 1. When you do that, so now R minus L plus 1 is the range, right? So how many you have done it is saying. So when you're doing this n times, this operation you'll have to do n times. So when you're doing that, you will have to maintain this r minus l plus 1. So whichever in which operation you will get maximum, so you will have to maintain that maximum and display it. So this is the problem statement. I think you guys have understood. Even if you don't understand, don't worry. Okay. And also they've said when after an operation, it may happen that a is not equals to b. So you can arrange a in any order in such a way that you make a equals to b. So rearranging also possible. When rearrangement is possible, so in that case we'll have to it is very important. You'll have to understand here. First, this is array B. We have array A as 0, all 0. 5 elements we have, which is all 0. Now, okay. Now the question comes. We'll have to make 5 1 0 5 1 0 1. So we have 0 here, but you'll have to make this 5. You'll have to make this 1, and here it is 0 only. You'll have to make this 1. And since they've said rearrangement is possible, so when rearrangement is possible, what we'll have to do is we'll have to consider all this as 1 only. Like what I'm trying to do is I'll consider L as 1 and R as 3. This is 1 based indexing, that's why. Okay, when I consider that, I'm choosing these 3 elements, and when I'm choosing these elements, now in the question what they said, you can increase all the range values to 1. So when I'm doing first operation, I've got this. Now what is your R minus L plus 1 value, which is 3. 3 minus 1 plus 1 is 3. Okay. So why I took in the combined, the reason being is that I want to maximize this R minus L, and in the last what we can do is we can make certain arrangements. It is possible. Okay. Yeah, it is possible. So that's why I took all this as a combined in order to maximize this. You have understood this concept, I guess. So okay, this is it. You have done that. Now in the second operation, since 2 zeros you need, you have 2 ones you need, you have. Now there are 5 operations, you have done 1, still 4 are remaining. So in the all 4 operations, you take L and R as 1 only and try to do this. Okay, so here R minus L plus 1 is going to be 1 only, but here you have got maximum is 3. This is your answer. Even if you do third operation, let me do it again. Choose R is equal to 1, L is equal to 1, R minus L plus 1 is going to be 1 only, and then your array will look like something this way. Now when you do fourth operation, your array will look something this way. When you do fifth operation, your array will look something this way. I'm choosing this only. R and L both is this only. So now your array and array B is somewhat looking similar, but it's not same. So in the question they've said rearrangement is possible. So why can't you rearrange to make that? You make this rearrangement and make array as 0, then make 5, then make 1, then make 0, then make 1. Now A and B both are equal, right? So yeah, 3 is the answer in this case. But why did I choose as you said, like as I said, like all whichever non-zero elements are there, so I will try to club that, and when I'm clubbing that, I'll try to increase all that non-zero elements to 1 in one operation, in because when I do that, I'll get R minus L plus 1 as maximum. That's why I wanted to do that. Okay, so yeah, this is the problem statement, and this was the first test case. Now let's try to consider second. In the second, we have 3 to 1. Now n is 3, array B is 3 2 1. So okay, initially my array is 0 0 and 0. In the first operation, since all elements are non-zero, so I'll take L as 1 and R as 3, which is like entire array I'm taking. And now R minus L plus 1 is going to be 3. So when your range is this, try to increase everything by 1. So this is your array. Okay, now one you have got it. Now you try to take this L as 1 and R as 2, and this is going to be second operation, and R minus L plus 1 is going to be 2, because we are choosing only 2 subarray. Okay, this is in the second operation. The last operation, take L as 1 only, R is also 1 only, and R minus L plus 1 is going to be 1, because I will be taking only this. Now increase 1. Now both A and B are equal. Okay, so when you have done this operation, see 3 to 1, which is maximum 3, so we'll have to return 3 only. In the last example we have 5 times 1, and then okay, we'll consider that. Let's consider that. In this example you will understand something, and based on that we'll try to make formula. So this is array B. Now my array A is 0 0 0 0 and 0, right? Okay. In the previous examples, what I was doing, I was taking how many non-zero, sorry, positive numbers, positive elements are there in the array. So here we have 5. So it in the previous example I was taking whole entire array. In this also let's try to take whole entire array. L as 1 and R as 5. It is 1 based anything, that's why. And R minus L plus 1 is going to give you 5 entire array. So when you have chosen entire array, all the elements value increase by 1. Okay, so now only it is equal, both A and B are equal, but still you have 4 operations left. So in this 4 operation, now we'll have to choose L and R, which should be within the range only. So let's say you choose this. When you're doing second operation, L is 1 and R is also 1, and R minus L plus 1 is 1, because one index you have chosen. Your B, your A array is something like this. Now you can't decrease it, right, any element. So this will never be possible. Okay, this will never be possible. So that's why in the first whatever I've taken range, it is not correct. Now I'll have to validate this. So how do I validate that? What I'll try to do is, here the most important thing is to come into picture. You'll have to count how many positive elements are there. Here we have 5. What is the sum of the entire array, which is 5? Okay. If that is the case, then you can't do it. What I'm trying to say is that in you have 5 non positive, I mean 5 positive elements, and then the sum is also 5 only, and you'll have to do 5 operations. So you'll have to take one element and do it. L is 1 and R is 1 if you take, then in first operation this will take into picture. In second operation you can edit this, sorry, increase this. In the third operation you can edit this, sorry, increase this. In the fourth you can increase this. In the fifth you can increase this. So after doing 5 operations, both A and B are equal, and in every case you have taken L equals to 1, R equals to 1. Here you have taken L equals to R equals to 2 both. Here L equals to 3, R equals to 3. So your R minus L plus 1 is 1 only. In all the case it is 1 only because you have taken one element. So the range is 1 only. At max you have taken 1 range only. Okay, so how do we solve this? I think here I have written something that will give us a clue. I'll take this was third example. I'll take first example also. It was 0 5 1 0 1. This was the thing. So in this case your count of positive elements are 3, and sum of the entire array is 7, right? So what my idea, in the contest came into picture is that um, what I'm trying to do is I'm trying to take how many count is there, which is basically positive numbers are there. Those many I want to club it together, and in the first operation I'll try to increase by one, as said in the question. Why I'm trying to club it? Because I want r minus l plus 1 to be the maximum. When I want this to be maximum, so I want to take as big subarray as possible. So that's why I was taking count number of thing. When I take count number of thing, right, so in that case your initially sum, I mean all elements are 0. So now when you're taking the 3 elements, right, you can take only 3 elements, not more than that, because rest 2 elements are 0 only. So when you have taken these elements in the sum, uh, like in the first operation you have got sum is 3, which is equals to count. The remaining sum whatever you have, remaining sum, which is going to be sum minus count, right, which is going to be 7 minus 3, which is 4. Okay, this is 4. And how many operations you are remaining? There were 5 operations to be done. One operation you have done, taking the big subarray and making all elements as one, and you have remaining n minus 1 elements as our operations, which is going to be 5 minus 1, which is 4. 4 operations you have. Now see, your remaining sum is 4, and the operations you need to perform is 4 only. So it is possible, right? Like in each operation, you try to take the range as 1 only, and try to increase its element by 1. If you do that, it will be possible, right? It is possible to make a equals to b, and in the first operation only, since you have taken all the positive elements on the one side only, clubbed it together, so you have got in the first operation only what is the maximum of r minus l plus 1. Okay, so in this example it is holding good, but let's try to consider the same thing in this example. I think you are getting right. uh, just you'll have to think over it and then you'll get. So in this example we have positive sum, you can positive numbers you can say, or count you can say, which is 5, and the entire summary is 5 only, and we have got how many operations to do? We have got 5 operations to do. So the remaining sum I'll calculate, which is going to be sum minus count. Why I'm taking sum minus count? Because all the 5 elements I want to be clubbed it together, okay, in the first operation. So it's like I'm doing all this clubbing together. Sum is 5, count is also 5, your remaining sum is 0. So which means first 1 operations you have done, now remaining 4 operations are there, but you have got 4 remaining operations, but your remaining sum is 0, which means in these 4 operations now you can't choose any sub array or something like that to increase its elements, because in the question they have said you have to choose in every, you'll have to do n operations, only exactly n operations. In every operation you'll have to choose l and r, which will be within the bound. So in this 4 operation, if you choose any l and r within the bound, and then when you try to increase its value, then remaining sum is 0 only. So it's like your sum of array element will be increasing, and it will not be equals to b. So something we have done wrong here in this case, right? So it's like something we have done wrong. So there are 4 operations remaining, okay, and then where sum is 0. So it's like if you do 4 minus 1, like in each operation I want to increase 1, so it's like 4 minus 0 if you do, which is 4. So in the first operation, when you have done this remaining sum minus count, right, you have taken the entire array, which is r minus l plus 1, which was like 5 minus 1 plus 1, which is 5, like your answer was 5. But like you have taken all the 5 elements together in the one operation and increased all the value by 1, but it was not supposed to be done in that way. So the remaining sum said, like you had 4 operations still remaining, but your remaining sum is 0, which means all the clubbed elements whatever you have taken together, in that case some elements had to be let out in order to increase those values in this remaining 4 operations. Okay, so remaining we have 4 operations and your remaining sum is 0. If you do this 4 minus 0, which is going to be 4. So in this first operation we have taken 5 elements together. So in that you try to remove 4 elements. When you try to remove 4 elements, uh, your answer is going to be 5 minus 4 only. Like initially I have taken 5, this was my answer only, but since there were 4 operations and remaining sum is 0, so we need some elements to be left out in order to make in order to increase those values in other operations. So what I'm trying to do is, whatever this value I've got in the first operation, I'm trying to decrease it by the remaining operation, 5 minus 4. So in a formula way, if you try to do it, so initially your answer will be r minus l plus 1 and remaining sum is this and your answer is going to be decreased by this answer minus 4. 4 is like remaining sum minus number of operations, right? I'll take this as diff, which is going to be n minus 1 is the number of operations minus remaining sum. So you'll have to decrease your answer by diff. I think you guys have understood, right? Like it was remaining sum 0 and then 4 operation we had. So which means we need still 4 elements to be left out from the initial whatever you have chosen. So in such a way that in each operation I'll take 1 and try to increase this value. Yeah, like greedily I'll try to increase this value in such a way that a equals to b, and whatever initially we had chosen, so we had to let out these 4 the remaining operations, whatever we had, those we had to let out in order to make into different operations. We'll have to perform these 4 element to be increasing different operations. So I think you guys have understood what I said. So let's try to let's try to write pseudocode. In pseudocode, what we'll have to do is first in the array B, we'll have to count positive element. Let's take positive element count or something, just count. Okay, first step is this. Second step is count sum. Third step is count remaining. Third step is take answer. Your answer will be the positive element count, right? Initially. Okay. And now we'll have to count the remaining sum. Remaining sum is going to be sum minus positive element count. Positive element count. This is the remaining sum. Now you'll have to check if the left operations will be, since there are n operations had to be done, one operation is done here, so it's like n minus 1 operation is left. If that is greater than remaining sum, in the third in the third example we had remaining sum as 0. It may be case the remaining sum is equal to, let's say, 2, and you had answer as 5 initially, and you had operations n minus n as 4. So in that case, what you'll have to do is you'll have to let out only 2 subarrays. Like you have still 2 remaining sums and 4 operations to be performed. So it's like in 2 operation you will get this 1 value, right? So in the 2 operations you'll get 1 value. Your remaining sum will be 0, and then n minus n minus 3 will be going to be 2. So so whatever the value you had chosen in the first one, in that case we'll have to remove 2. So it was like what you are doing, n minus 1 minus remaining 0 doing. So we will take into diff this. Okay, it is like n minus 1 minus remaining sum, and at the end from the answer we will just decrease the diff and print this answer. I think this is pseudocode, and let's try to code it up. So yeah, let's take input. We have test cases, and for every test case we have integer n. you have taken, and then we have array b array elements. Let's take b elements. We have taken b elements. Now when you're taking b elements, let's try to take positive count, which is initially 0, and then sum will also be 0. What we need to do is we'll have to check if this b of I is greater than 0, then positive count is going to increase, and then all the elements sum we are putting into sum. And initially your answer is going to be, as I said, is positive count. Okay, now you'll have to take remaining sum. Your remaining sum is going to be sum minus positive count. Now we'll have to check if your the remaining operation you have done, so n minus 1 is the remaining operation. So if the remaining operation is left, right, if the operation left is greater than remaining sum, right, remaining operations left is greater than remaining sum, so in that case your diff is going to be n minus 1 minus remaining sum, and in the answer you'll have to decrease this. It's like you have taken more positive values together, so we'll have to separate it out some values in order to let those values to be increased in the other operations. Okay, and at the end we'll have to display the answer. Let's try to run it. It's getting passed. Let's try to submit it. What is the problem name? Addition on a segment. Oops. Addition on a segment. Yeah, let's try to submit it. In the contest it was accepted. Let's try to see if it is getting accepted or not. Yeah, it got accepted. So I think pretty much I've said all the steps and explained you. If you guys have understood, please like the video, and if you have not, then try to comment, and then I'll try to explain there. So yeah, thank you guys for watching the video.